So we have a question from geometry, I think. Let's start by visualizing the cube and its diagonals. So start by observing that, let's say this is a face diagonal, this, then of the 4 body diagonals, 2 would be intersecting it and the other 2 would be symmetric with respect to it. So the minimum distance of both of the 2 would be the same from this face diagonal. And as we chose an arbitrary face diagonal, we can say that of all the possible combinations of the face diagonal and the body diagonals, they would be either intersecting, making the minimum distance 0. So that in that case dl1 l2 would be 0, but we have to find the maximum distance, so we have to find the distance between the non-intersecting ones. We can choose any arbitrary face and body diagonals which do not intersect. So let's say this is the x-axis and this is the y-axis, this is the z-axis, makes the coordinate of this point 1, 0, 0. This is 1, 1, 1. And we'll choose the body diagonal which passes through these two vertices. So this point of the coordinates of this one is 1, 0, 1, this vertex, and this vertex is 0, 1, 0. So the equation of the face diagonal becomes 1, 0, 0 plus t times 0, 1, 1. This is the face diagonal, and the body diagonal becomes now we need to find the minimum distance between these two. So that distance would be the line would be along the line which is perpendicular to both of them. So to find the vector perpendicular to both, we'll take the cross product. We'll get 2i cap plus j cap minus k cap, this cross product. So we have the vector along with there will be minimum distance between the two. Now we'll need to find the points where this vector intersects. So let's keep this on hold. Let's start with the points on these two lines. So that makes the general form of general point is 1, t, t on FD, and on VD it's plus t1, minus t1, 1 plus t1. Then the vector along the two becomes t1, minus t1 minus t, 1 plus t1 minus t. This should be perpendicular to both these vectors, which gives us, say, dot product of this with this vector gives us minus t1 minus t plus 1 plus t1 minus t equals to 0. That gives us t is equals to half. Dot product of this vector with this gives us t1 plus t1 plus t plus 1 plus t1 minus t equals to 0, which gives us t1 plus t1 plus t1, 3 t1, t gets cancelled with minus t plus 1 equals to 0, which gives us t1 equals to 1 by 3 minus 1 by 3. So the 2 points become 1 comma half and 2 by 3 comma 1 by 3 comma 2 by 3. So distance between the 2 points is under root 1 minus 2 by 3 squared is 1 by 9. 1 by 2 minus 1 by 3 squared is plus 1 by 36. 1 by 2 minus 2 by 3 is again plus 1 by 36, which is equals to root 1 by 6. So the answer is A. So the trick was to identify that any pair of non-intersecting face diagonal and body diagonal will have the same minimum distance.